Hi and welcome back. So first of all, let's go back into our body modules. And in here, let's unpin the view and we will decrease our number range to 0 again, so it is easier to work with. I think our expression is still in our transform node. It is, so that is great. So let's dive into main body loop, and in here, right after the divide pattern, which we created in last part, we will create a new subnet, which we will call would pattern generate. So let's dive into it. And the first thing I will want to do is, well, rename our null, of course, as usual. And we will want to separate our scales from our horizontal and vertical, because both horizontal and vertical are just wooden beams, and scales are absolutely different logics. That is why we will have to separate them into two different generators. So let's do that with a blast node. So we will ask it to keep only the wood pattern scales. So delete non-selected. So keep primitives. So that is our scales. Let's actually put it to the right, and to the left it's going to be non-scales, or just wood. And we'll delete the scales. So the next step is to create a subnet, which we will call wood, and we will run it for each primitive. Yes, we want to merge the results being checked on. And let's color it into a blue shade. Yes. And let's dive into it. So in here it contemplates that 6 is not a valid group. Just to make sure that it doesn't conflict with our main body loop, let's rename it to for value wood. For value wood. So in here we get our first beam, and just to make it more visual, so let's see what we have here. Both of them are scales. Let's change our seat just for now, just because I want to get some bigger horizontal or vertical areas. So yeah, that's good. Yeah, we have this vertical one. So we added 12 to our seat in divide pattern. Let's actually color this subnet right away as well to a darker blue shade. Yes, and in here, let's go back into our wood. So let's see which one it offers us. This one, okay. Just for their testing purposes, we're going to blast the biggest one. So it's number 3. So group 3, and we want to keep it. So in the wood, we have only one that it can actually show us. It's just going to be more visual when we're going to do things. So it's going to be easier for you to see what is actually happening. So now, the next thing we want to do is we want to create a seed, because our wood is actually also going to have some random elements. So call it seed. We will color it into a red or pink and edit parameter interface. And in here we want to have a seed. So we will create a wood pattern. Well, just wood seed. It's not really a pattern now. It's wood that we are creating. So wood seed, create a seed. Yes, and in our seed, we want to grab the global seed. So let's go up and up and up and up we go. More up. Yes. And we want to grab our global seed. So now let's go back and back and back. And here we want to paste copied relative reference. And we want to add to it the stamp value, because for every wall we run, our wood is going to be slightly different. So up for value wood and 0. So that is our seed right now. So let's create a null, which we will call in, and it will branch into a following division, because the next step for us is to identify whether we are running over vertical or horizontal wood. So let's get a blast again, which we will call vertical. So in here, we want to delete non-selected if its wood pattern is equal to vertical. And yes, indeed, we're going to keep it. But the other one, we want to rename it to horizontal. So horizontal. Delete non-selected. And yes, well, delete non-selected. So yeah, true that here it should be nothing right now. So horizontal. Now we're going to deal with vertical, since we have the vertical piece in here. And the next step we want to do is we want to divide it into a beam. So let's grab a divide node again. and we don't want the convex polygons. We want the breaker polygons, and we want 2 by 7 here and 2 by 7 here, and here just something big like 100. So let me uncheck the markers. We don't need that anymore. So that is a good start. But sometimes when we have those borders, as you saw, when they're too narrow, we don't actually want to divide them. So we're going to create a switch, which we will call check for, oops, no caps, check for border. And in here, we're actually going to grab a wrangle, and we're going to call it border. And if it is a border, we just want to mark it. We're just going to say that it has an integer of a border, which is 1. And make sure it runs over primitives. So right now, there is nothing in our switch. So what we want to check is, we want to check whether the height of our wall, so we're going to check the in, dy maximum, and we're going to subtract dy minimum. If it is smaller than 0.3, then it is a border. We don't want to divide anything that is smaller than this. So apply and accept. And currently it is not true. Well, that's true because this is actually 3. So that's true. So we do want to divide. However, right now, our divisions are very, very equal. It is very rare in real life you're going to see wood beams that are exactly the same size, especially if it's an old house that was like manually built without a new technology, so to say. So the way we're gonna make our beams uneven is, let's imagine that this is our division with some cut out window, for example. And let's divide it something like this would work, I think. And something like this, and here. Yeah, well, let's imagine that they're equal size, okay? And, well, the thing we're going to do, since we have all these points now, we will check them against the original geometry that we had input into our subnet. So, and those points are here, 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 and here, and also here. So this is the points of the original geometry. And this way, with our point cloud, we're going to find all the new points. So this one, this. So all of those points are new ones. And since we only want to move new points, because those new points create these new edges, we will move them randomly. However, if we just move them randomly, what we can end up with, if, for example, this point we moved over here, and this point can be moved over here. So what we will have is something ugly like this. And this just, yeah, I don't know who built that house, but he doesn't have a talent for that, that's for sure. And that's not what we want. So the way we're going to do it is we're going to derive our random number from the position x. And why the position x? That's because if we have this, so this is our y, and this is our x. And if you look closely, position x of this point is the same as position x of this point, because they were cut vertically. So they have equal position x, which means equal random number, which means same offset. Yay! So that means that all of the points will move nicely like this. So they will move together. So in this one, if it moves here, then this one also moves here, and we get something like this. So that is the general idea behind the algorithm of how we're going to move everything. So let's implement it inside of Houdini. So let's grab a wrangle node. So attribute wrangle, because it's how we're going to implement it. Let's plug our in into the second input right away. We will call it uneven division vertical, because we're also going to have a horizontal one, as it features slightly different rules. So, well, you can actually guess which slightly different rules I'm talking about, since here we're checking position X, there we're going to check position Y. So make sure it runs only once. Let's make it bigger. And in here, we will need to have multiple things. Well, first of all, what we want to do is check whether the point is a new one. So after we did this, if it is, move it based on its position x. So, well, that's all we want to do. Easy, right? So, before we do all of this, we will need to have a couple of variables. So first of all, we would need to grab the position, so vector position. We would run pcloud, so we would need that. We would also need a random offset number. So let's grab that. And, well, seed, of course, very important. So seed channel, seed. We would also need to know our maximum offset, so maximum offset, and I would go with something like 0.04. I think that works nicely, because we do not want this division to be like right in your face. It has to be gentle, almost on like subconscious level, that this stuff is not perfect. It has like a special touch, because I think if you make things perfect, people immediately know that something is really wrong with it, and that is what we want to avoid. We want to give this houses like a hand touch. Like a feeling of a hand touch, like it was done manually by someone. So, yeah. And we also would need a vector for new position. So we'll put it in here. The new position that will be assigned to our point. So, yeah, so let's start. So let's check whether it is a new point. So for int I is equal 0, I is smaller than number of points in the first index input, I plus plus. And in here, we will grab our position. So point 0, p channel I. And we'll run our pcloud, so PC open, and first index input p channel from our position, something small like 0.1 would work, and only 1. And if nothing was found, so our point doesn't coincide with the old geometry, that means that it is a new point. So this will go inside of this, so here. So if it is, move it based on the position x. So now we can identify our random offset, which is a random of our seed plus position x. However, this might not work, and this is kind of a very strange thing, so I will apply and accept this. So if you go and we will look at this 18, 15, 16, 17, so yeah, 16, 17, 18, it looks like they have the same position in x. However, that is not entirely true. Though it shows you the same numbers, I guess there is some other numbers after this one that just doesn't show, which are different. So when you compare them, they're different. So what we have to do to avoid that, and I would actually even make a float for that here, position x. We would need to make a position x variable, which we will limit. So what we're going to say is we want to int our position x multiplied by 100 and divided by 100. So we keep only 2 more numbers after the comma. And that is what we're going to use. So position x. And yeah, this is our random seed. So we're going to fit it between its original values of 0 and 1. And we're going to go minus maximum offset and maximum offset. So after we've done fitting, I think that's it. Yeah, that's correct. So our random offset is identified. So now we will make a new position, which is our x multiplied by random offset. And now we can set point attributes. So set point attribute, yes, and p channel, we want to modify that of point number I, and new position we put in here. But instead of set, we say add. So it's going to add to the existing attribute the new value of new position. So apply and accept. And that's what we get. And again, you see that this number 16 doesn't move together with 17. So let me check if I decrease this. So now it goes together. So 16 just doesn't move together with us. Is it because it's too close? So let me actually check if we decrease the range of our pclouds with something like 0.5. It might just work. Yes, it just was, yeah, it was thinking that it is not a new point. So make sure that this is small enough value. I would even make it smaller. So yeah, as you can see, they slightly moved. And please note, this also do not move, which is perfect. All the corners also do not move. And it is exactly what we want, because we want to keep the general shape intact. So now we want to do the same for the horizontal. So I will just actually copy all of this. I will plug it into the horizontal. And for now, let's actually mirror it. Yeah, like this. So it looks a bit more tidy. And for now, I will make it delete selected, just so we can see what we are doing. And in here, we do not want this ones. So let's put it something like 100 and 100. And here we want to put 0.2. Yeah, look what our uneven division does right now. It's funny, yeah? But what we want to do is we want to modify it a bit. So, and here we do not want the position X. We want position Y. So let's check everything. Position Y in here. And it's position Y. And here we want to also make it into a Y. Yeah, I think that should work. Okay, no, it doesn't. No, sorry. So vector Y 17, an initialized variable pos Y. But we just initialized it. Oh. Okay, sorry. I put it pos and a capital one. So apply and more stuff. Okay, let's see if it just doesn't update. Yeah, it just didn't update. So as you can see, our stuff also moved. And you might notice that we're kind of distorting the general shape here a bit, but we will have a frame over it, so trust me, no one will ever notice that. So, and it's the same for check for borders, so we have that. So let me merge it together. And yeah, here we just delete the selected, so we have this one. Beautiful. So one more thing before we go, we haven't made our random seed, so that is our seed, and here as well, seed please. Yes, and we will plug this one, this beast, into the seed to our wrangles. So paste copied relative reference, yes, paste copied relative reference, and yeah, as you could see, it immediately changed a bit. So if I put something else, we have something slightly different. How awesome is that? So I will actually keep this number here, so we have a different seed numbers. So yeah, that's it for this video, and I will see you in the next one where we will be dealing with UVs. So I'll see you then. Thank you for watching. Bye bye.